Hello everyone. We are going to be working on day 3 of Trig for Algebra 2. I hope you're all doing well and I hope you're ready to take notes because taking notes will help you when you do your homework. Okay, so here we go. So for this day, before I get started, I do want to let you know that I will be doing a quick review of the SOHCAHTOA that we were doing before in case you were having trouble, because I did see some people having trouble on their homeworks and their classwork. So stay tuned for that. If you think you're doing fine with it, you can just look at it and so on. It's just to keep you fresh with that. Okay, so let's get started. What we're going to be talking about today is about angles in the coordinate plane. Okay, so let's make a little note of that. That is angles in the coordinate plane. So what that means, it sounds so fancy. What that means, I'll get this higher up. Sorry. Is if you have a quadrant, and this is your X and this is your Y quadrant, right? As you know, this angle here is 90 degrees, right? So when we measure angles, they always start from right here, right in this X, positive X axis part. So angles starting here, going this way, that would be considered 90 degrees, right? So we call this spot right here 90 degrees, right? And if you keep going, then you'd say, well, that's another 90 degrees. So then they call this one 180 degrees. And then if you keep going, you can call this one 270 degrees. And if you keep going, this would be 360 degrees. But originally it was 0 degrees because that's where we started. So it goes 0 degrees, 90 degrees. It keeps going all the way around this way. So keep a note that when you go in the positive direction, that is counterclockwise, that's positive angles. And if you go down and around, if you go down this way, that would be a negative degree angle. Okay, you may be like, wait, what does that mean? So I'll give you some examples to help make sense. Okay. So you're gonna determine the quadrant in which the angles line. So you're gonna draw. These are going to be your directions. Draw the angle. Draw. Oops, that's an W. The angle given and state the quadrant. Okay, so here's how it goes. Draw the angle given and state the quadrant that it lands in. That is the quadrant of what we call the terminal angle. That is like kind of where it terminates, where it ends, where it stops. Okay. So number 1. So let's say I gave the angle like 210 degrees. I'm going to do 210 degrees. I'm going to do number 2. I'm going to do 80 degrees. You know, I'll do a couple of these and show you how this goes. So I'll also do, I'll do 3. I'll do 315 degrees just to show you how these all go. Okay. So 210 degrees looks something like this. We go, all right, I'm going to draw little axes. Of course, this is X. That's why. You don't have to be perfect with this. Just kind of get the idea. And just count and just keep in your mind. Just remember, because you'll end up memorizing this because it becomes natural, that this is 0, this is 90, this is 180, this is 270, and then this comes back to 360. You got to get that in your head that that's what's happening. 0, 90, 180, 270, 360. That says 360, a tiny little 360, but it is still there. Okay. Okay. So I'm going to See if I can grab a different color to show each angle to make it look a little prettier. Anyway, so you go from I want to get to 210. So I know that that's 90, 180, 270. Ooh, that's too much. So it must be around, well, this is 180. So this is about maybe this angle here, because 45 is right in the middle. 45 degrees from here would be in the middle. So this would be 225 right here, but I don't want to go that far. So I'll just go right there. And I'll say, yeah, it's about 210. Believe me, I'm not going to sit there and measure it and be like, oh my God, that person's off by a little bit. You just know that's about 210 and you label it. You write 210 degrees. But believe me, they used to take off points on the Regents if you didn't draw that. To say, hey, we start here, we go around this way, and it's positive. Okay? Now, that's it. And what quadrant is that in? Oh, quadrants. Can't forget those. Remember, if you want to label your quadrants correctly, you got to do them in order of making the letter C for correct. That's 1, 2, 3. That's a 3, 4 in our Roman numerals, right? So what quadrant is the landing in? Right there. So your answer is draw this and say quadrant 3. Okay? That's it. Now we're going to do the next one. Next one's 80 degrees. That's not so bad. So you go 80 degrees. So you know, you know, if you want to be all like neat about it, this is 0, this is 90. So you're like 80? That's not too far. It's pretty close. It's like right there. I label it 80, right? And then I have to say it's going from here, and I draw a little arrow. Some teachers take off points for not drawing that arrow. I quite frankly believe if you just draw this, it's fine. Okay? You can, you know, if you don't put the arrow, it's not at the end of the world. Okay, so now what quadrant is that in? That's in quadrant. Oh, this one was, I want it in red. This one's quadrant 1, because that's quadrant 1. Good? Next one. And remember, drawing this is part of the assignment. Okay. Number 3, 315. Okay. So 315. So I go, okay, wow. I know this is 0, 90, 180, 270. Even though I know this is 90 and 270, the biggest focus is 0 and 180, okay? All the way here is 360. So 315, that's about right there. Okay? So it's about 315 degrees. And of course, I can't forget this part. This time I won't draw an arrow, because I said you don't really have to. So I want to give examples of both, okay? And I want to say the answer, quadrant 1, 2, 3, 4. And that's it. So that's a major piece. But this is only positive angles. What the heck would happen if I said to you, okay, now find number 4. I almost wrote a 2. You guys saw that. Shh, be quiet. Okay, so now let's try angle. Let's try something like negative 40 degrees, or 5, negative 200 degrees. Right? Here's a couple of them. That and that. Sorry. Okay. So of course I'm like, okay, I'm gonna make this. I'm gonna make this. Right? I'm just getting them ready. And then I'm gonna get myself here. I'm gonna say, okay, I would normally go up if it's positive, but because of the negative, I go down. Okay? So this is gonna go down. And it only can go up to 40 degrees, so that's about 40 degrees. I mean, halfway through is 45, so that's about 40. So I would say negative 40. Okay? That's in quadrant 1, 2, 3, 4. There you go. Now for this one. This one is negative 200. So that means I would normally go up if it was positive, but since it's negative, I go down. Okay? So remember, down for negative. Okay? Up for positive. Okay? And I just wrote over there and you guys don't know what I'm writing. That's all. Okay, so now this is negative 200. So I'm going to go this way. I'm going to go, well, all of this is 180. right? This would be, I know this is 180 this way, but it's also negative 180 this way. So I have to go further than negative 180. So it's going to go, that's negative 200. And that's that part marked. You can put an arrow if you like, or you can just draw that. Okay, that's the same thing. So that's drawing the angles and stating the quadrant. Almost forgot. 1, 2, 3, 4. So it's quadrant 2. There you go. You're able to do, if you follow this, much of your homework. Okay. The only thing I want to also ask you is to state. Hold on. Is to be able to say, write the angle as a write the positive coterminal angle. Write the positive coterminal angle. Coterminal angle. Coterminal. What the heck does that mean? Well, coterminal is a concept I want to talk about a little bit. So, for example, if I talk to you about, get the book back so it's a little higher again, sorry. So if I talk to you about the measure of angle, angle negative 45 degrees, okay? That, if you drew it, would look like, if you remember what we just did, that would be here, right? That's negative 45 degrees. But if you go the other way, and I'm going to use a different color for that. If you go the other way, this way, what would that be? So that would be going 180, 270, and then what? That's plus another 45. So basically that would be 315. How do I get that? So like, how do I get that number easily? So here's what I do. I go, we like to write the positive coterminal angle, write the positive coterminal. I'm going to say the smallest positive coterminal angle. That means when I say the smallest positive coterminal angle is we want to rewrite the angle as a number between 0 degrees and 360 degrees. That's it. Between 0 degrees and 360 degrees. So you look at negative 45. Is that between 0 and 360? No. You would look at that and say, you are too small. Okay? So what you do is you add full circle. If I go to this negative 45 and I go 360 this way or 360 this way, I go back to the same spot. Remember, knowing that you start from here, 360 is all the way around, 360 is all the way back. From here too, if I go 360 in this direction, I end up in the same spot. If you stand up and spin and do a 360, you're going to end up facing the same way. So 360 degrees. From that negative 45, you say it's too small, so I take negative 45, and I go, hey, add 360 to that. That's what you do. You add 360 because it was too small. And if you do that in your calculator, you will get 315 degrees. And that's your answer. You want to rewrite this, so negative 45 is the same as 315. I'm going to give you a few more. What about if I say negative 100 degrees? I want you to rewrite this because that is a number between 0 and 360. all right? That means the smallest positive coterminal. So you go, oh, that's too small. So I'm going to rewrite it this way. I'm going to say too small. This is how you work it out. So you go negative 100 plus 360, and you get 260. Done. All right, wait, that's fine. You can be like, this is not so hard. I just like, if you just add 360, do I always add 360 no matter what? Well, what about this one? What if I have 400 degrees? That's not between, you know, that's like beyond. So if you were to draw that, you would say 400 degrees. How do I draw that? That would be like 360 and then some, right? It would be like around here or something. See how that goes and wraps around more? So how do I say that? So that one I would say is too big. So since it's too big, I do 400, and instead of add 360, I subtract 360. And guess what I get? 40 degrees. So that is the same as if I had gone 40 degrees this way, is the same as 400 degrees. Not 40? Yeah, 40. So then is the same as 400 degrees, coincidentally. They're both with the 4s, but yeah, that's that. All right, now to go over some basic trig that people are having trouble. So if I give you a triangle, and I call this PAT, and I make this 5, 12, 13, and I ask you, I'm going to be asking you for the sine of P, for the cosine of T, for the tan of P, mixing it all up. So you have to use SOHCAHTOA. So SOHCAHTOA, this is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Tangent does not use hypotenuse. No hypotenuse. So if I ever see tangent, like I see tangent P, you better not have 13 in any single way, because that clearly means you're not doing this at all correctly. Okay? So you have to look at this and say, okay, wait a minute. I may look at this and say, this is the hypotenuse no matter what. That is going to be the hypotenuse because it is opposite the right angle. Opposite the right angle is a hypotenuse. However, this being adjacent or opposite, I don't know. It depends. It depends on who you're talking about. If you're talking about angle P right here, then this is opposite. If you're talking about angle T is right here, then 12 is adjacent. So it all depends on the angle. So when they say sine of P, I have to say what's opposite P. So the side opposite P is 12, because that's opposite P. And hypotenuse is 13, because that's hypotenuse, okay? And so cosine of T. Well, cosine of T is the side adjacent to T, 12, and then hypotenuse, 13, because this is adjacent to T, because that's the angle they're talking about. And tan of P, I go to P, this angle right here, and I go opposite over adjacent, OA. So opposite P, 12, that's opposite P, and adjacent to P is 5. Okay. I hope that little review helps clarify a little bit. Please move on to homework number 3.